Okay, this is trigonometry section 4.7. If you have a book, we're on page 414. Inverse trig function. Here we go. We're going to try to introduce the concept to you and why we do what we do, and then we'll take our calculators and take a look at how your calculator understands things and just having it. So here we go. As you know, as you're supposed to know about inverse functions, what you're supposed to do is you're supposed to take, if you have y equals sine x, which looks like this, that's the graph of it, and you want to find the inverse, you switch x and y like I did right here. You switch x and y, and then solve the thing for y. And the only way to peel that sine off of that y so it stands alone is to inverse sine both sides, so you end up with this, which is this. And fundamentally, I mean, right down to the grassroots of what an inverse function is, x and y switch places, right? Which means my x-axis, which used to have angles on it, and my y-axis, which only had 1 and -1, because that's what sine's trapped in between, have switched places, domain and range. Now I've got my angles on the y, and I've got -1 and 1 trapping it on the x. You see the switching? And if I graph this function on this new set of axes, because domain and range got switched, I no longer have a function. The way this thing is going right here is actually referred to in geometry as serpentine. It's like a snake. Okay? And we have a non-function, and we only study functions. Especially in calculus, you study functions only for a long, long time. And so you're going, well, then what do we do? And the answer is you restrict the range of this function so that we're looking, the range of this graph, so that we are looking at only a piece that is a function. Now, that means we could choose to go from here up to here and erase everything else. That would work. We could also choose to go from here down around to right there and erase everything else. We could even come down here and go further. It seems to me the obvious choice is the one that goes through the origin. Keeps things tight, keeps things near small numbers. Okay, so if I were to erase this part right here, and this part right here, then I would have a function. And these angles right here, remember the angles are on the y-axis, the angles of restriction, in other words, the range restrictions here are from pi halves to negative pi halves. That's all you're allowed to do. You go from -1 to 1, and this little branch of the inverse sine curve, that little tiny branch right there, grabs all of the values of inverse sine from -1 to 1 without repeating them, making it a non-function. You see it? Now, on a unit circle, what that means is, from this graph right here, which we put out on a couple of axes, if we were on a unit circle, what that means is that you can only find inverse sine values. Your calculator will only give you inverse sine values on the unit circle between negative pi halves and pi halves. From here to there. That's it. And sine is positive in the first quadrant and negative in the fourth quadrant, which means we're going to get all the range of values between here and here. Get all your positives here, get all your negatives back here in the fourth quadrant. But we don't say that it's, I mean, we go from negative pi halves to pi halves so that none of these are included. And so the inverse trig function has x values, no, yes, no, y values that are between negative pi halves and pi halves. And that's the only values that your calculator can return. Now, if you want to see if your calculator understands this, ask it to graph inverse sine. You go to y equals, make sure you're in radian mode, of course you will be, since that's what we were doing a few minutes ago. And type in inverse sine of x. And go zoom trig. Now, the reason why mine's a little flatter here, the reason why mine's flatter is because it's out of, I mean, the axes aren't numbered the same. Pi halves is 1.57. Look where I have 1. 1.57 would be this long on the x-axis. So the thing's been distorted. It's been squashed. Mine has, because of the drawing, the way I numbered the axes. These are numbered about the same if you look at the tick marks on the axes, or anyway. So it stands up a little straighter, and it hardly looks curvy at all. It's a really boring little piece of graph. but it's the only part that we're allowed to look at, since making it go further would make it serpentine and a non-function. And so inverse sine functions are severely restricted, the first and fourth quadrant on the unit circle. Now let's take a look at cosine. Cosine starts up here, and its inverse looks like this. What portion of that could we restrict to make sure we cover all the values from -1 to 1, but have a function? This one doesn't go through the origin. We can't go from negative pi halves to pi halves because it would duplicate all the positives and give us no negatives. So it seems to me the best possible choice, in my opinion, is to go from 0 to pi. Oops, other way. Because that will give me all of the values of inverse cosine from -1 to 1. It covers it all, is a function, and goes from 0 to pi. Seems like a reasonable thing. And on the unit circle, 0 to pi is from here to here. Again, cosine is positive here and negative here. And so this range of values for cosine will pick up all of them from -1 to 1. So cosine is defined in the first and second quadrant of the unit circle, and from 0 to pi on the graph. You okay with that? Cosine is found first and second. Sine is found, inverse sine is found in first and fourth. Okay. Oh, I think I had this left over from when I was doing problems. This isn't, those of you watching, that doesn't belong to this lecture. Sorry. Okay. Now, if you are watching, look away a minute or you're going to get dizzy because I got to go over to the other board. So hang on. And I got to put it on the ladder so there's no glare, and it keeps pinching my hand. So hang on. I hope I'm going to have it kind of like this. I hope the cord is going to be long enough. Okay. All right, take a look here. Oh boy. Ooh, that's really awful. Sorry, you guys that are in class, you're just going to have to look through the ladder. Put it right about here. That's about even with the other one. All right, so now we're going to discuss inverse tangent, and it's on this board right here. Okay. All right, so the regular tangent curve, several branches of it look like this. I know it's really crammed together, but you just practice graphing these, so you should be able to tell. That's what this looks like, right? Goes from negative pi halves to pi halves, goes through here, and bends a little bit as it goes up. If I switch places with x and y on that to give me that one, then all of these angles are now on the y-axis, and all my asymptotes have become from vertical are going now horizontal, and so the inverse looks like this, right? Y'all agree with that? Again, a non-function. Pretty clear which branch we want to focus on here, don't you think? The one that goes through the origin. So if I get rid of this one and this one, then I have a piece that's left over that is a function, and it is trapped between negative pi halves and pi halves, just like sine. So if we were to put this idea here on a unit circle, we will find inverse tangents from here to here, but not including those. Sine actually includes them. For those of you, I'm sorry, if you're watching the video, I'm going off screen. Over here, the sine, we had dots right here, which means that when we actually had a -1 and a +1 here, because there's no asymptotes in sine. Here, we range it from negative pi halves to pi halves, but it can't get to those. It's only trapped in between, strictly in between. So the y values on this will be strictly between negative pi halves and pi halves. And so sine and tangent have a lot in common, but the difference is right here. Tangent can't get to pi halves and negative pi halves, sine can. Okay? So sine and tangent are defined in the first and fourth quadrant. Cosine is defined in the first and second quadrant. And that will make more sense to you as we discover that, and maybe you already know this, tangent and sine are odd functions. Cosine is even. That has to do with that. That's the reason why cosine's a little bit out there with everyone else. Okay. So if you're convinced of that, now we're going to talk about how we deal with it in real life problems. That was just a conceptual explanation as to why we have to restrict the inverse trig functions so that we are actually talking about functions. Just for fun, everybody graph inverse tangent. See if you get that one branch like that. See if the slope looks like. Second Tangent x graph. It appears to do that. If you want to know if the asymptotes are in the right place, then you can go down and graph the horizontal line pi halves. And then in y3, graph negative pi halves. And sure enough, those are the asymptotes. Traps it. Okay? All right, I'm going to move this back now, so if you're watching, don't get dizzy. Ladder's hard to move. Hang on. I got stuck. All right, so I've cleared this board off, and now we're going to play around with what we just learned. Okay, so that discussion of everything that we just had, and he does it in a little more detail. I don't feel like it's necessary. We're going to take a look at example 2 at the bottom of, wait a minute. Oh, sorry. Pretty important to do example 1. We really haven't gotten that far. However, if you'll turn the page, you can see he talks about cosine. After that, he talks about tangent, and we've already talked about all those. So we've gotten pieces of it after that. After talk about how we actually calculate and do things, I try to understand it. In example 1, so if you've got a book, you're going to have your eyes on example 1 because there's not going to be much going on the board right now. It says, find the exact value of each expression without a calculator. Now, here's where you're going to have to train your brain when you see that sine inverse thing to train it what it is you're looking for. The inverse sine of 1/2 means, try to remember to think this way. The inverse sine of 1/2 means find me an angle whose sine is a half. Yep. Now, a half is a positive number, which means we're only looking in the first quadrant. Because all the negative inverse signs are in the second or in the fourth quadrant. Okay, so if we're doing this without a calculator, then what you're asking yourself is what angle? Because an inverse sine is an angle. It's an angle. It's an angle whose sine is a half. And that would be pi 6, wouldn't it? Think about a lay down triangle. Pi 6 has an opposite leg of a half. What?
Not to.
What?
Because when the inverse be. Oh, it's. Oh, never mind. I got it.
I am going to go ahead and put this on here so you can see what kind of triangle to imagine in your mind or draw. Inverse sine of 1/2. You have to train your mind. You're not signing 1/2. You're asking yourself, it's like this. It's like saying the sine of some angle that I have is equal to 1/2. That theta would be the inverse sine of 1/2. Wouldn't it?
Okay.
Isn't that how you get rid of the sine algebraically? So you can see that when you're asked to find the value of inverse sine of something, you're looking for an angle whose sine is a half. So you imagine, you say to yourself, okay, I'm doing inverse sine, that's first and fourth quadrant. 1/2, the number 1/2 is positive, so I'm in the first quadrant. And I've got to draw a triangle whose sine is a half. And that's a lay down 30, 60, 90 because the opposite leg would be the short one. Right? What angle is this? 30 degrees, which is pi 6th, is the answer to that. That's the angle whose sine is a half. See it? This is hard to acclimate to at first. I understand that. Okay, look at the next one. Inverse sine of root 3, negative root 3 over 2. Which quadrant are we going to look in? Boy, inverse sine is defined in first and fourth quadrant. The negative ones are in the fourth quadrant.
Wait, why the fourth quadrant?
I just erased it. It's defined between negative pi halves and pi halves, which is fourth and first quadrant.
Oh. So inverse sine will always be first and fourth.
When you're done with it, yes. There's a lot you may have to do. If your angle turns out to be in the second and third quadrant, there's some reconciling you have to do. That's why this is a difficult section. But for right now, they're asking you for the inverse sine of negative root 3 over 2. And because this is negative, we know to look in the fourth quadrant. Because the negative inverse signs are in the fourth, the positive inverse signs are in the first. Covers them all between first and fourth quadrant. Are you with me or not?
Yeah. Yeah, I just think the reason why it isn't in the third quadrant as well.
Because that would cause our sine curve to be serpentine. We'd get us into the third quadrant, past the pi halves.
Why? Because it's okay. That actually makes sense now.
Okay, yeah, we can't have a serpentine function, so we're stuck in the first and fourth quadrant. So what we need to do is draw ourselves a triangle in the fourth quadrant whose right or whose opposite side, which is the vertical leg, is long, because it's root 3 over 2. We want the long leg to be root 3 over 2, which means we got to stand this one up. So that this is negative root 3 over 2 here, when this is 1. Do you see that? Now, what angle did we open up to make that happen? Negative pi thirds. So the answer to this is negative pi thirds. Could we also call it 5 pi thirds? No, you cannot. Because the answers that you get from doing this must be between negative pi halves and pi halves. 5 pi thirds is all the way around here, and that's way outside this range. This right here is between negative 1.57 and 1.57 if you want to know about the actual numbers. 5 pi thirds, which is coterminal with that. 5 pi thirds is way bigger than this. It's right around 5 point something. Way bigger than this. So you cannot name this angle with this positive one right here because you're outside the range of acceptable angles when you're using inverse sine. We can only call this negative pi thirds, and that is in between these two. I told you what to get used to. Okay, take a look at the next one. C says the inverse sine of pi halves means what angle do we know of whose sine is pi halves? And the answer is there isn't one.
Because it's greater than 1.
Because it's greater than 1. The author's trying to trick you here, and it sounds like he did a pretty good job, except for Trey found out the result a little quicker. But he's trying to trick you here. You are not signing pi halves. If you were signing pi halves, the answer would be 1. You're trying to find an angle whose sine is 1.57. Sine can't get past 1, or can't get above 1 or below negative 1. This is undefined because he's mixing angles with inverse sining on purpose to try to get you, and it sounds like he did. So be careful with that. That angle will not show up here. The answers to these will be angles, not sitting in here. The things sitting in the parentheses should not be angles. They should be fractions that we're familiar with, like 1/2, root 3 over 2, root 2 over 2, 1, 0, but not an angle. This angle, the actual value of that thing right there is greater than 1, and you cannot find an angle whose sine is greater than 1. It's undefined. So he tried to sucker you for it, and I think he did. It's because you're brand new at this. It's okay. Look at the D part. Now this one, now they're really going to throw it at you. Inverse sine of the sine of pi ninths. Like you've been taught since first grade, or maybe a little after that. You do it in parentheses first. So ignore this for right now. What is the sine of pi ninths? I don't know. I don't know what that is because pi ninths is not something familiar. But just don't find it, Trey. Just look at what we would do. We would say, okay, sine of pi ninths, pi sixths is awfully small. Pi ninths is even smaller. This, folks, that's the sine of pi ninths. This angle right here is pi ninths. So what I'm going to do is I'm just going to say, I'm going to put a theta right there, and I'm going to say the sine of pi ninths is theta. That's not right. No, I'm not going to say it's theta. Sorry. I'm going to say it's y. Because if this is 1, which it always is so far, what we've done so far, sine of pi ninths is going to be the length of this leg, isn't it? I'm calling it y because it's vertical. And so now I want to find the inverse sine of y. question is, what angle do I know of that has a sine of y? Pi ninths. Pi ninths has a sine of y. In other words, one end to the other. That's what inverses do. Just a second. As long as the angle is in the first or fourth quadrant, because if it's not, you've got something more to do. But if this angle that you're signing and then inverse signing is between negative pi halves and pi halves, which this is, then these undo each other. Equals pi ninths. Do you want me to go through that again? Yeah? You do this first. You say the sine of pi ninths. With the pi ninths is not familiar, Taylor, so we don't know what it is.
Yeah.
All I know is that its value is the length of that vertical leg. I don't know what the length of that leg is, but I know that that is the sine of pi ninths.
Okay.
I should have put a theta there. It's kind of redundant. This is the angle pi ninths. And if this is a 1, then the sine of it is this length right there. Don't know what it is, so I call it y. So now I'm going to inverse sine y. And now my question is, you got to reverse it around in your mind, and you got to say, what angle do I know of whose sine is y? And the answer is pi ninths.
So can't you just cancel them out after you know that?
If this angle is in that range of values, yes. If not, if it's somewhere else, you've got some things to do. But this is your first case of doing this. So yes, this undoes this so long as this angle that we're talking about inside here is between negative pi halves and pi halves. You can just say what the angle is.
What makes you have to do something else?
You'll see it very shortly. Okay, so we have the inverse sine of the sine of 5 pi sixth. That 5 pi sixth is not in the proper range of values. Can you see why this is not my favorite lecture? You guys are not having a good time, I can tell. So this time I'm going to do the of the sine of 5 pi sixths. Now, where is 5 pi sixths? What quadrant?
That's the second.
Second quadrant, where inverse sine is not defined. So I can't just say this is 5 pi sixths, because ultimately the answer is going to be the inverse sine of something, and those answers can only be between here and here, and that is not. So I can't just let them cancel out and say the answer is 5 pi sixths. You're right. It's in this quadrant. So the first, like I did over here, I'm going to find this. Okay, now here's stay with me. That 5 pi sixths is over here with a reference angle of pi sixths. This is pi sixths. This is 5 pi sixths. I'm using the reference angle 5 pi sixths, and because it's a familiar one, and this is 1, this is 1/2, and this is negative root 3 over 2. Not that it's going to become important, because the sine is all about this. So the sine of 5 pi sixths is 1/2. So this right here gets replaced with 1/2. So now I'm inverse sining 1/2, because this turned into 1/2.